Welcome back, students. In this video, we're going to cover lesson 3-6, proving angle relationships. Let's see. Get this set up here. Wrinkled paper. Okay, standard for this lesson is GR 1.1, listed below the title. So we got some postulates and some theorems we're going to talk about before we move into the actual problem, practice sort of stuff here. Sorry, I've been sick, guys. Actually, videoing this, I was out today. This is toward the end of school. Actually, school just let out about 30 minutes ago as I'm doing this video. So, it's the first thing I've actually been able to do in the last probably almost 48 hours. But anyway, so starting at the top left, let's try to zoom in just a little. All right, so postulate 3.10. Hold on, we got some zooming issues. There we go. Should be a little better now. Postulate 3.10. Now we don't have to memorize these. They just give us a few of these chunk at a time, and we're going to use these to prove some stuff below. We actually have some real math. So some of you guys will be glad for that below. So anyway, postulate 3.10, protractor postulate. So you guys know what a protractor looks like. I normally have one, but I don't at the moment. But every angle has a measure that is between 0 and 180. And if you look at the protractor, one end is a 0 and the other end is 180. It's also a straight line. That's also half a circle. Just future reference. The straight line part, though, we'll talk about below. All right, 3.11, angle addition postulate. So saying that D is in the interior of angle ABC if and only if angles ABD and DBC equal ABC. And I know that sounds like Charlie Brown's mom, wah, 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 wah. So if you have angle ABC, so D is on the interior if and only if ABD plus, let me write a better D here, plus DBC equals ABC. So it's just saying that this guy has, if he's in the middle, then the two sides of him make this whole angle, is what it's saying. All right, theorem 3.3, the supplement theorem. So if two angles form a linear pair, then they are supplementary angles. So linear pair, so straight line, it's a pair of angles created off of a straight line. So this is a straight line. Talk about half a circle, 180. So the other side is 180. So this plus this equal 180. They're a linear pair and they are supplementary. Theorem 3.4, complement theorem. If the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. So here, so it's saying the non-common sides. So here, of two adjacent angles. So this is the side they share. These are the non-common sides. If this guy, let me find my red pen. I like the red box better. If these two are 90, then they are complements because they would equal 90. Oh, sorry, we got a little sideways there. Now I'm going to zoom out just a little because it kind of messes with the ratio here on the screen. Okay, so theorem 3.5, properties of angle congruence. So just like numbers, we've talked about equals and congruence. That means the same thing. Congruence, of course, has to deal with shapes, and equals has to deal with numbers. So that in mind, just like we talked about, 2 equals 2, so angle 1 equals angle 1, and that's a reflexive property. A good way to remember that, if you look in the mirror, you see your reflection. So reflective, you see yourself. So and this will come into play later when we have angles or sides that make up two triangles. It has to be congruent to itself. So when you look in the mirror, you see yourself. Angle 1 is congruent to angle 1. Number 2 is equal to number 2. Okay, so think in those terms. All right, symmetric property. So if 1 equals 2, then 2 equals 1. Or if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Kind of like, as I've said, 2 plus 1 equals 1 plus 2. Kind of the way to think of that. All right, and then the transitive property, we get into 3, more than 2. So if 1 is congruent to 2 and 2 is congruent to 3, then 1 and 3 have to be congruent. So, say if this one is 40 degrees, so they're congruent. Well, if this is 40, then this is 40. So it's like the Spider-Man meme. I said that in class and nobody got it. So either way, all three of these are congruent, then 1 to 2, 2 to 3, then 1 to 3. All right, below, the theorem 3.9, perpendicular lines intersect to form 4 right angles. So if lines are perpendicular, if one side's 90, the other side's 90, they all 4 have to be. All right angles are congruent. Well, in order to be right, it has to be 90 degrees. And 90 equals 90, right? And then perpendicular lines form congruent adjacent angles. So again, same thing. And that goes back to vertical angles. Those two things kind of cross here. Excuse me, sorry. All right, so let's go over here. So theorem 3.6, congruent supplements theorem. Angles supplementary to the same angle or congruent angles are congruent. So let's say, let me think of a way to put this. Okay, I know these all three look the same, but we've talked about we can't make assumptions. All right, so it's saying that angles supplementary to the same angle or congruent angle. So let's say this guy is 110 degrees. So supplements, this guy would be 70, okay? Whoops, 70 degrees. So because 110 plus 70 equals 180. Okay, so if one is, excuse me, if one is supplement to 2, and let's say 3 is a supplement to 2, 110 again plus 70, then that would make 1 and 3 have to be congruent. Abbreviation, supplement to, okay, yeah, this is just an abbreviation of this. Sorry, Blair Witch. This is just an abbreviation for this statement. Angles supplementary. So, and we can do this on our notes, so you guys feel free. I know we're writing a lot. Angles supplementary to the same angle or congruent angles are congruent. So if 1 and 2 equal 180 and 2 and 3 equal 180, then 1 and 3 have to equal. See, if 1 and 2 equal 180 and 2 and 3 equal 180, then these two have to be the same. Theorem 3.7, congruent complements theorem. So same thing as this, except we're talking in 90 degrees. So let's say, so angles complementary to the same angle or to congruent angles are congruent. And there's the abbreviation again. It says if 4 and 5 equal 90. Well, let's say 5 is 65 degrees. 4 looks smaller, so it's like 25 degrees. So 25 plus 45 equals 90. All right, so if 5 and 6 equal 90, then 4 and 6 have to be congruent. So if these two have to equal 90, 90 minus 65 is 25. All right, this pen does not, well, I don't write very well, but the crinkled paper and the pen and being sick, I got all kind of excuses. Okay, theorem 3.8. So vertical angles theorem, and this is an important one because we will talk about vertical angles all year long. And I mean all year long. So if two angles are vertical angles, then they are congruent. So 1 and 3 are congruent. So remember I said, so two lines that cross each other and make the X here, the ones across from each other, so left to right, up and down, are going to be congruent. So think of it this way: 1 and 3, 2 and 4. Let's see if I can make it look a little bit darker. There we go. You guys can see. So 1 and 3 are congruent, 2 and 4. Okay, now to a little bit of math. All right, so example 2 says Maylin is installing shelves in her room. One of the brackets she chose for her shelves is shown. If the measure of angle 3 is 55, what is the measure of angle 4? Now, I wrote this and forgot to erase it when I was adding our little word bank to the sheet. So kind of giving you a hint here. So this is a linear pair. See, 3 and 4 are two angles that come off of a straight line. All right, a linear pair equals what? Equals 180. All right, so 180 equals the measure of angle 3 plus the measure of angle 4. All right, so they said that 3 was 55 degrees. Oops. All right, so you're just going to subtract 55 from both sides. We've got 180 equals, we substituted. So start thinking in terms of proofs. We substituted measure of angle 3 for 55 degrees because that's what they told us. That was our given. And we're adding it to measure of angle 4 because they're a linear pair and they equal 180. So we subtract 55 from both sides. Sorry, this is a absolutely terrible 55 I've written here. I'll try to clean it up some, but you know, some things you just can't make better. Okay. All right, so 180 minus 55 is 125, so the measure of angle 4 is 125 degrees. All right, example 2. As you can see, the hint's already there. It's a linear pair. Notice this line. So this is a 45-degree angle. They're asking what this is. You're going to do the exact same thing from here. So I'm going to move down to example 3. Let's see if this helps. Yeah, it's fine. This is fine. Okay, example 3. In the figure, angle ABE and DBC are right angles. So let me try to do this. We will. So ABE. So here, I think we can see that. Let me maybe zoom. Well, I don't want to zoom too far. Hold on. I can see better on the screen than I can in real life. That's terrible. Okay. So that guy's a 90-degree angle. And I'm going to go above it. Or, yeah, I'll go above it. DBC. So you see the red covers ABE and the blue covers DBC. Because they're right angles. Okay. All right, so complete the proof. Our given is that those two guys are right angles, and we're trying to prove that ABD is congruent to EBC. So the angle here and the angle here. We know the bigger parts. We're trying to see about the smaller parts. All right, so statement 1 says that, and actually let me zoom out so you can see the theorems here. We're limited on space, as you can see. All right, so statement 1, angle ABE and DBC are right angles. That was our given. Statement 2, the measure of angle ABE is 90, and the measure of angle DBC is 90. So the notes had definition of congruence. I scratched that out. It's actually the definition of right angles. So if these guys are right angles, they equal 90. So It's good that we could see this mistake, but sorry. But yeah, so definition of right angles. All right, so statement 3 says that ABD, so this little guy, and EBC are complementary. All right, so obviously this guy makes up this right angle and this guy makes up this right angle. So that is true in the theorem. So I can't show it all on the page. So we have 3.4. 3.4 says that if the non-common sides of two adjacent angles form a right angle, then the angles are right angles. Well, so these are not adjacent angles. They have this guy in the middle. So we can scratch this off. So now we have two blanks and two theorems. So this should be easier. All right, so theorem 3.7, congruent complements theorem. Angles complementary to the same angle or congruent or two congruent angles are congruent. And then let's see what theorem 3.10, all right angles are congruent. So let's see. That may not be the right theorem for the other one, but so these guys are complementary, and that's the theorem 3.7. That's the congruent complements theorem. So ABD and EBC are both complements. It's even confusing me. Hold on one second. 3.7. Excuse me 1 second. Okay, sorry. This is what happens when I try to multitask during a video. Just a second. Okay. Excuse me. And then ABD and EBC are congruent because of, and again, the theorem 3.10, that's not right. That's all right angles are congruent. Maybe it is the 3.4. Hold on. If the non-common sides, okay, the non-common sides, yeah, this, okay, yeah, so it is 3.4, not, so, my bad. So yes, these guys are congruent because the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. Okay. But I believe we should have reversed that, or it's still kind of funky in my head. But again, I've been sick and I'm full of excuses in this video. So, example 3, check to the side here. So, let me just come in here a little bit. You have 1, 2, 3 spots. 1, 2, 3 blanks. There's not this. So, just look at what you have here and you should be able to figure out what angle goes in there. What angle number, excuse me. I'm going to flip over now. Okay. Zoom out. Okay, so example 4 on the left, complete the proof. So we're given that angle 1 and angle 2 are congruent. We need to prove that angle 3 and 4 are congruent. So before I mark anything, so these are vertical angles. So 1 and 3 are congruent because they're vertical angles. 2 and 4 are congruent because they're vertical angles. So you see up here it says vertical angles theorem. We got symmetric property and a couple of transitives because we got to move some stuff around. So I'm not going to mark what we know by vertical angles. I'm going to just start by marking what they tell us so that 1 and 2 are congruent. 1 and 2 are congruent, and that is given. All right, so now 1 and 3 are congruent, and 2 and 4. So that was what I was saying before. So I'm just going to do it like this. 1 and 3. did. So we'll go blue, 2 and 4. Yeah, you can see that. Okay. And that is, like I said, vertical angles theorem. So all right, so vertical angles theorem, we'll cross that off. All right, so now we got 3 and 1 are congruent. Well, if you look up here, 1 and 3 are congruent. Remember the symmetric property, if 1 is equal to 3 or congruent to 3, then 3 is congruent to 1. So symmetric property. All right, so now if since 1 and 3 are congruent, and we already know that 1 and 2 are congruent up here, we can replace 1 with 2 because 1 and 2 are congruent and 3 and 1 were congruent. So we substituted our substitution property. They got transitive. Okay, well, transitive, that's fine too. We'll just, either way, we'll just, aggravating. Semantics. Okay, fine. And I'm the one that put the dang word bank up there, so I have nobody to blame but me. All right, so and if 1 and 3 and 2 and 3 and 1 and 4 and 2 and 4, then 3 and 4 have to be, and that's going to be, and I really, that one is correct for transitive property. The other one could have been substitution. It goes either way. All right, so over here you have the same thing or something similar. These are not, well, they are vertical angles. You see this up here. So you got 3 blanks and 3 options. So see what you can do with that. Hopefully no issues. If so, though, let me know. All right, example 5. So again, we have some more vertical angles. I'm going to try to scooch this down. The videos ran a little longer than I intended. That's okay. Let's see. Yeah, if you guys were absent on Thursday, I left after the first class, so I did not do this lesson yet with third or fourth block, and I was out today, Friday, because I'm still sick. So apologies to you guys. I'll see you on Monday. Let's see. Reach out if you have any questions. I'll be checking. Be doing grades and checking my focus and all that this weekend. Okay, example 5. Complete the proof. They give us that 1 and 4 are congruent. So we're going to say 1 and 4. I did them backwards. That's okay. All right, 1 and 4 are congruent, and that was our given. All right, so 2 and 4. Well, those guys are congruent because hopefully you already said they're vertical angles. You see down here, vertical angles. And there's actually, hold on. Excuse me. Zoom all the way out, and we're going to come down because we have a little further of a word bank here. My bad. This dang. Okay, well, that doesn't work. All right. I'm just going to write these words in a little better that aren't showing up on the screen. My apologies. Okay. All right, we're trying to prove that 1 and 2 are right angles. All right, so 2 and 4 are congruent because they're vertical angles. All right, so if 2 is congruent to 4, then 4 is congruent to 2, and I hope you already knew that that was the symmetric property. Hopefully some of this stuff, I know I see it 3 times a day, every day, I get it, but hopefully I'm hoping some of this will stick. All right, so notice we have a couple of blanks here. This is what these are for, and of course that one, these other ones, the reasons are on the right. So number 4, Now we're trying to prove that they're right angles, so that's the bottom one. That'll be the one we prove. So got a couple of blanks in between. So if we know 2 and 4, we know 1 and 4. How about 1 and 2 goes here? And let me see. I have the notes, so totally winging it. Yeah, 2, 4. Yeah, 1 and 2. So angle 1 congruent to angle 2. Cross that one off. So angle 1 is congruent to angle 2. All right, so something you should notice, and I should have said before, but it's okay. We'll get there. So notice that 1 and 2, this is aggravating. So 1 and 2 go right here. They are created off of that straight line, so they are a linear pair. So why are they congruent? Oh no, that's not right. It's this one. They form a linear pair. My goodness, what a video. Linear pair. So, how about that? 1 and 2 form a linear pair, and that's the definition of a linear pair. See, this is linear pair. This is how you know it's been a rough couple of days. Okay, almost done. Number 5. All right, so if we got 1 and 2, 1 and 4, 2 and 4, 4 and 2, 1 and 2. That leaves 1 and 3. I think I had this, but it should have been 1 and 3. So angle 1 is congruent to angle 3, and that is the transitive property. Because if 1 and 2 and 2 and 3 and 1 and 3, we hadn't talked about 3, but 3 would be congruent to 1. That's the definition of a linear pair. How did this is what happens when I create my own word bank. But either way, so because these two guys were congruent and a linear pair, and these two guys were congruent and a linear pair, they made 4 right angles. So the bottom here is that angle 1 and angle 2 are right angles. Yeah, sorry that I messed that up so bad. Okay, other side. You see there's only 2 blanks, only 2 options here. Made it super simple, luckily, because I would have botched it somehow. So let's do the little summary and get out of here before I make this video any worse. So your extra credit on this one is if you watched the video and you heard me complain about or talk about being sick or making excuses. How about that? So, given angle ABC is supplementary to DEF, and DEF is supplementary to GHI. All right, so is ABC supplementary to GHI? Well, it says that this is supplementary to this, and this is supplementary to that. Let's see. And the answer is yes, and it is the congruent supplements theorem. Oops, I got a little lazy there. All right, number 2, I'm going to let you answer. Let me know below on the paper if you understand, you're somewhat confused, or you're really lost and need help. There is no bad question to ask. I'm here for you guys. So until next time, have a good night. Again, I'll see you guys Monday. Or actually, if you're watching on YouTube, I'll see you next video. Consider liking and subscribing. Thanks.